We then look at the global biomass production. Depending on how you're calculating, I would say that we have agriculture including straws in this region. I would think it's more in this region than this region, but at least this amount we're producing from agriculture and forestry in this region. And then we add them together, and then we compare to how much do we use in the world globally primary energy. Well, we actually more biomass resources available than the total use of energy. And then you remember this figure that it was considered zero in 1980. Now today it's considered being 13% of minor importance, but in reality it is more than the total use of all coal, all oil, all natural gas, all these 80% in the official statistics. But of course the biomass is for free in very many ways, so you don't count it. Conclusion, we can see that natural resources relatively equally distributed between the rich and poor countries at high level, with principally enough biomass to cover all the needs we have with respect to energy and food and materials and all those type of things. Because what we are using as food is becoming manure and things like that. What we are using as waste from the crops we can use for biorefineries and things like that. And what we're using for like books and furniture and so on, we can use as energy source or some other source.
It's possible to sort of compare the pilot plant unit into the digestion, and the digestion of a ruminant like cow is a very good example of that. So the cow is chewing the grass and it is swallowing it, and there are the acids making the hydrolysis of the homogenized biomass, and then it is recycled for some time, and then the bacteria in rumen, they are producing the organic acids and other substances. And later on in the digestive system of a cow, the animal is collecting back even the proteins and lipids which are accumulating into the microbial cell mass. So it's very effective. So why don't we design our plants according to the same principle? And future biorefinery is a field where we receive different wastes and no waste will come out, but it will be further processed. And in above, we have been testing it. We are in the beginning.
Okay, so here we are standing in front of our new technology on the bioreactors, and this is a new design of bioreactors and biorefining itself. And my name is Anssi Suhonen, and I'm coming from Savonia-University of Applied Sciences. And I was responsible for the mechanical designing of this bioreactor here. And this bioreactor here is based on Dr. Hakalehto's ideas and patents on new prospects and new developments in biotechnology. And beside me here is Emilia from Poland, and I will give the mic so she can introduce herself and explain what she has done.
Okay, so my name is Emilia Denbur, and I work at the Wrocław University of Technology in Poland. And we were testing this child of our Finnish friends for 2 months in Poland using Polish feedstock, Polish waste, and we could see how it operates and adjust it to our conditions. So we are now quite familiar also with this technology, and it was a really nice time to see how it works.
The volume for this reactor is from 200, let's say 200 liters to 250 liters of biomass, which we can process with this bioreactor. And the remaining volume from the reactor is about 100 liters of gas volume here on the top. So that's the volume we have been running at.
Okay, so maybe from the beginning, because we were first cultivating the bacteria in the lab at the university. Then we brought them here to portable unit, where it was. It is also an invention of Dr. Hacaletto, when it was cultivated for some time, and then it was fed here to these fermenters. And there we added also food for the bacteria, so it is 7-liter volume each of them. And they were cultivated at set temperature, which you can adjust here. And after some, I think it was 20 hours or so, we just pumped them with these pipes to the reactor. We mostly did it through the circulation pump, so they could be directly mixed with the whole mass.
I would say anything that is organically degradable, any kind of waste mass.
Using different microbes.
Using different microbes. So the main thing is that we optimize for each biomass and each waste the different microbe population for when we are talking about the different end products. What we measure here is we measure the pH, and we can also control that. We measure the temperature, and we can control that using the double shell design of the reactor. Then we measure the O2 content, so we can control the gas flow into the reactor. We can measure the glucose, and then we can get some perhaps different gas flows into to control the different levels. Was there anything else? Yeah, exactly. So the exhaust gas, what is coming out of the reactor, is also analyzed. Okay, so we have tried this now using like a batch process. So now we pump the reactor, then start running the process for a day or a couple of days, and once we have thought that now the end products are there from the sample, then we can open the valve here and collect the data and pump more mass into the reactor, so we get the final product into the stabilizer. Yes, we can. Yeah, we can. Actually, the next process would be to get this working continuously. So every time we are getting substrates formed, then we can pump more matter in from the bottom, and the ready-made substances are flowing out from the top. The outcoming gases, they are of course coming from the top. Then we measure the flow volume with the sensors there, and then the rest of the gas goes into the gas analyzer. So we analyze the gas content, but then we are, of course, this is a pilot station, so we are not collecting the gas. We are blowing it out. We monitor the concentration. We know how much we can produce. And from that we actually learned that hydrogen is really being produced in quite nice amounts.
You can also control of course the composition of gases if you run the process in a lower with less oxygen dissolved, then it will be more hydrogen, and depending on your parameters you can control.
On this Above project, we have run 3 different kinds. One was from the pulp and paper industry. It was the wastewater treatment plants sludges that was firstly processed in Finland. Then Emilia can tell about Poland.
In Poland, we had 2 different types of waste, but both actually food waste. So the first one was from the potato chip factory. So we got from them potato peels that were before washed, and just these peels with a little bit of potatoes. And then we took 2 substrates and mixed them together. First we add potato peels, and then we later added some bio-waste from restaurants, so like kitchen bio-waste. So it was.
Sweden, you can tell as well.
And in Sweden, it was located at a chicken farm, and they took all the residues from the chicken farm, which they could get, so some manure, and then also the intestines and the feather.
Yeah, the slaughter waste from the chicken.
Yeah, and also later they added some fruits that were also available on the farm.
So this system here is the heating system for the hydrolyzing and also the bioreactor. So we just heat the water up with it.
So maintain the temperature?
Yeah, to control the temperature, exactly. So it's just a water cooker. Actually, this is electric, so we haven't collected the gas. But our next step will be eventually using the biogas to heat up this process. That's the next phase of our process.
And besides energy, we get all these useful products, chemicals, nutrients, fertilizers, and not forgetting clean water and clean air.